NO2.
I'm going to do this sideways.
2 plus NH4.
Wait, what number is this?
16. 2 SO4 yields CrSO4
This is long.
plus NH4NO2. Okay, much bigger problem and much scarier looking as well. Let me make sure that we're getting it all on tape here. Okay. All right.
Wait.
Okay, that can fit. Mine isn't fitting.
Like, this does not fit. Even
You can go sideways if you need to. Okay, so I have chromium, I have nitrogen, I have oxygen, nitrogen repeats, hydrogen is here, sulfur. So I got 1, 2, 3, 4, 5 elements. So over here, chromium, nitrogen, oxygen, hydrogen, sulfur. Okay, a few things that I'm thinking when I look at this. First thing I think is, yuck. Because everything, I mean, I've got a lot of parentheses problems going on. Nothing is isolated by itself, so I don't just have like oxygen hanging out there by itself. Everything is attached to something else. These nitrogens here are even split apart from one another, which adds a little more confusion to the math. And so here's the thing we got to think about. When I see a problem this in depth, the thing that concerns me is my math. If I get any part of my math wrong along the way, I'll never get it right. And I'll just become frustrated. So I've got to take my time thinking about it. So let's go ahead and count up our atoms. How many chromiums on the reactant side?
1.
How many nitrogens on this side?
2. 4.
Got 2 there, and I got 2 there. So yes, 4. Oxygens.
8. 4.
Okay, 2 times 2 is 4 here, plus that 4, so 8. Hydrogen.
8.
4 times that 2 is 8, plus that 4.
Hydrogen over there?
I'm sorry, that's not hydrogen, my bad. Thank you. 4 times 2 is 8. I was looking at oxygen.
Bless you.
Sulfur.
1.
Just 1.
Plus the
Okay, so over here, bless you guys. Chromium, how many on this side?
1.
1. How many nitrogens?
2.
1, 2. How many oxygens?
6.
8.
4 there, and 2 there.
8.
6.
Okay, hydrogens?
You add them.
1.
No,
4.
4 here.
And then 1.
Okay, sulfur,
1.
1. Okay, so now then, this could clarify some issues with me. Some things that are going to draw my attention. Kind of look across. One of the perks with this is everything's even as far as 1 chromium, 1 chromium. Everything else is like even numbers. So that's actually a good thing to see. I don't necessarily want to mess with things that are in parentheses, so I want to look specifically like maybe at sulfur. Okay, so let's deal with him first. Well, sulfur's even, isn't he?
Yeah.
So we can't really deal with him. Oxygen's tied up into this.
CR.
CR is matching up
yeah.
too. We don't have any choice but to dive into some of the ugly stuff here. So let's go ahead and look at.
Nitrogen? See this like.
Let's try this one because he's not dealing with parentheses. Let's try that. So CrSO4. It's going to have to add up to 8 along the way for right now. So I've got 6 right now. So I need 2 more, right?
Mm-hmm.
So let's put a 2 right here to try to at least get my oxygens to match up. So chromium stayed, nitrogen is affected. So I got 2 there now. Well, no, I'm
No, it's a
sorry.
4.
There's another nitrogen over here.
Where?
It's
Oh
a
yeah,
4.
yeah, 2, 2. That's going to mess with me.
4.
4. Hydrogen is 4 times 2.
8.
Then we got oxygen. 2 times 2 is 4, plus that 4.
Is
8.
Okay. Sulfur and chromium
We
stay
got
the
it
same.
balanced out.
1488. Oh my gosh, look at that.
Yeah,
See, this looked like a really
cool.
creepy problem at the beginning.
So don't we put just one to
Yeah.
Just put one everywhere. Oh,
One.
that's cool. Yeah, I did get it right.
I thought we were going to do something really spooky. Okay, now this could have got really ugly if I would have started with something else. And it would have probably still worked out, but I would have been too high in it, right? Everything would have been doubled or tripled, and then I would have had to reduce it. Luckily, I started out with the one that really needed adjusting first. And just so you understand my logic on that, was I wanted to start off with this one because I didn't want to deal with stuff in parentheses. And this one had nitrogen, which was what I initially wanted to look for to get nitrogen to go to 4 was my whole initial idea. Okay. Okay, is that a 3? No, it's not. Okay. Okay, so first thing I want to do is count up my atoms on each side. So aluminum, 1, iron,
3,
3, nitrogen, 2. So I want to transfer the elements in the same order over here. Al, Fe, and N. Okay, so count them up. How many aluminums on this side? Everything's 1, isn't it? Actually, it's real easy to see. Okay, so as I begin a problem, I got to put a lot of thought into it before I even write my first problem down, or my first thing down. And here's why. If I don't put some logic into it in the beginning, I could go off in a really weird direction and have some really long problems going on and not necessarily having to go that extra extent, okay? First thing I notice is aluminum is all by himself over here, and he does not have a subscript. The cool thing about that is if I get aluminum over here, it doesn't matter what he becomes, I can just put that number as the coefficient and he's going to be cool. Because there's no subscript to multiply him. If I put a 5 there, he'll be a 5. If it's a 7, he'll be a 7. So that's really nice when I see those, okay? The other thing I see is iron on this side is the same way that aluminum is. No matter what iron becomes over here, I just have to put that number here and he's going to balance. So I'm not too worried about aluminum or iron. I know they'll work themselves out pretty quickly. So what I am going to worry about is the nitrogen. So when I look across, nitrogen's 2 here and he's 1 here. So what do I want to do first?
make that 2.
Make this one a 2. Okay, so now aluminum gets changed to a 2. Nitrogen is now a 2. Iron did not change. So now look across, aluminum's 2, iron's 3, nitrogen's 2. So let's go ahead and get aluminum to go to 2. Okay, let's look at iron over there, because he's a 3. What can I do to iron over there? 3 here. Okay, 2, 2, 3, 3, 2, 2. Everything checks. I just need a 1 right there as a placeholder. Okay, so Na on this side is 1. Chlorine is 2. Na over here is 1. Cl is 1. Okay, so not too much challenge here, I don't think. The sodium is by himself, so that's cool. Chlorine's always going to be increasing by 2 over here. So let's go ahead and try to get this to go to 2. So I'm going to go here. So Na is now 2. Chlorine becomes 2. So chlorine now matches. Na needs to be a 2. So I'm just going to put 2 here. That becomes a 2. We're all already squared up. 1. Okay, so we got C's. How many we got?
17.
C's we do?
7.
How many H's do we have?
17,
17 on those. Oxygens?
2,
2. So carbon, hydrogen, oxygen.
carbon, 1,
Okay, carbon 1, hydrogen 2,
3,
oxygen 3 because I got 2 there and 1 there. Okay, so look across, 7, 17, 2. Okay, we've got a lot of different things to look at here. First thing is oxygen will always be in multiples of 2 over here. So I've got to make sure oxygens end up being even over here so they will match. Okay? So that's one thing I got to keep in my head. I always want oxygens to be even. Okay? Then the other thing I'm looking at is there's a huge gap between hydrogens, 17 and 2. Okay? Now here's the thing I want to look at. Will this hydrogen ever be able to be a 17? Why not?
No.
because that one's even and that one's
Yeah.
odd.
Yeah, this one's even, this one's odd. So that will never get to 17. So I might as well go ahead and get this to go up to something even. If I multiply times 2, will it be even?
Yes.
Okay. so let's do a 2 here. And 2 times 7 is what?
14.
14. 2 times 17.
34.
And of course, oxygen didn't change. So now let's try to get those hydrogens to match up to 34. What? 34 divided by 2 is what?
17.
Oh.
Okay, so hydrogen is now 34. That's what I was after.
It messes up
And
the
then
oxygen.
Oxygen is 17 there now. But I've got 2 here.
So 19.
No, 17 times 2 is 34.
I'm sorry, my bad. Thank you. 34 plus 2.
68. Why'd you get a plus? You said you never had him.
From here to here I do. 17 times 1. Oh, what do you
It's
wait, hang on.
17.
Yeah,
I need to start thinking for myself instead of just listening. 17 times 1 is 17. And then,
plus 2.
Plus the 2
Oxygen.
equals 19.
here a minute.
But it's
What am I trying to solve for? Oxygen, right?
Here.
Okay, and then 2. 19. Thank you. Okay. All right. So yeah, oxygen is messed up. It's not going to be where I want it to be. But that's okay because there's an oxygen here that maybe things can change with or whatever. But really, this is where the odd number is coming from because he's the 1. This will always keep things going in 2s. Okay? So that's probably not going to help me too much. But let's just look across. Carbon's 14 now. He's 1 there. Let's go ahead and try to get carbon to go to 14. Oh, he is 14. No, we want to get him to. We want to get that one to 14. So let's go here. What do we need?
14.
14. So 14 here. And oxygen's now 28
28.
plus
plus
17.
17. What's that end up being?
45.
Yeah.
So 45. Okay. So 14, 14, 34, 2. Still not even.
You can go 2 times 3.
You need
Okay. Okay, wait. Here's what I'm looking at now. Okay, if I've got to go up in something, remember that 17 was an issue from the very beginning, wasn't he? We talked about him. I mean, he's got to continue to be in an even situation. So what is 17 times 3? Is that an even number?
No.
So what's 17 times 4? Something even.
Some of them 8.
It's twice that amount, right?
68.
So times 4. So let's go ahead and do the carbon first. 7 times 4,
28.
28. 17 times 4. What we got now?
68.
Oxygen's not worrying. I'm not worrying about him at all because he's by himself. So let's try to get that one to go to 28. Looks like a possibility because I already got a 14. Oh, all I got to do is put something in front, don't I?
Yes, 2.
Okay, so carbon, if I want him to be a 28, he's got to be a 28. So now carbon's a 28. Okay, oxygen's changed now. 28 times 2. What's that going to be?
56.
Plus
Uh-huh.
17. Is that right?
Yes.
What's that now?
72.
3.
3.
73.
Yeah.
Gets ugly, doesn't it?
Yeah.
And this was the oxygen. 73. Okay. So now look across. 28,
But you can't make 70.
34. Okay, let's see if I can get that to go to 68 over there.
You just gotta put
So
you
just
just gotta
double
put 34.
Yeah, 34.
Okay, so let's go 34 there. Okay, 34 times 2, 68.
That changes.
Now 34 oxygen's there,
Plus the other oxygen.
plus 28, what was that? 56,
90.
90. So that now becomes a 90.
There we go.
And then
Okay.
you just have to put a 45.
Now I come over here, I can,
45
28.
times 2 is 90. 45 times 2 is 90.
okay, so that's 90.
So we got it all.
Okay,
You got it.
Well, that was hard, but it.
that is hard. Okay, so one thing that I always look at when I see big numbers like this is, can I reduce everything down like in algebra or in math? Can it reduce by a multiple of 4? Because that's my lowest number. Will 4 go into 45?
No.
So I'm probably even. I just always want to double check my math, make sure everything's working out. I think this does work out actually. Let me see, what number was this one?
10.
10, 4, 45, 28, 34. So, yeah. Okay, so I got calcium. How many of those do I have?
1.
One. I have carbons. How many do I have those?
1.
One. Oxygens.
7.
Good. 4 plus that 3 is 7. Hydrogens
3.
and phosphorus.
1.
Okay, over here, got them in the same order. Ca, C, O, H, P. Okay, 3 of those.
Yes.
Carbons, how many?
1.
1 there. Oxygens.
11.
Good. 4 times 2 is 8, plus that 3. Okay, hydrogens.
2.
2. Phosphorus.
2.
Good, because of that 2 there. All right. Okay, when I see a problem like this, my first gut instinct is yuck. I don't even want to attempt this. I think I'm going to go get lunch. I'll come back and think about it later. Okay? I'm going to not do that. I'm going to try to figure it out. Okay, see if there's any hope for my logic in here. Okay, the first thing I notice is PO is wrapped up in parentheses. That always causes me issues mentally, so I don't want to try to attack that if I can avoid it. Calcium is not, H and C is not, so those would be my primary objectives. This one right here, Ca, is 3, so it's always going to increase by 3s. This one right now is just a 1, so I'm going to use that as my first line of attack, okay? So I'm going to try to get this one to match up with that 3. So I want to put a 3 here. Okay, so now I got 3. Okay, carbons now change.
3.
So 3 there. Oxygens, 3 times 3,
9.
plus that 4,
13.
13. Okay, nothing changed with hydrogen or phosphorus. So now over here, I got my 3s lined up. Carbons no longer match, so let's try to mess with him. So carbon there is a 3. Let's try to get him to match. So 3 here. Okay, so 3 times H, 2. 3 times 2, guys.
We're at
6.
Okay, 3 times that carbon there.
3.
Okay, 3. 3 times that O, O3.
9.
9, but also have this one here.
7.
Oh.
17.
Okay, that's O, 17. And then, of course, this one didn't change, that one didn't change. So look across, 3, 3, 13, 3. Okay, phosphorus.
You
Okay,
can change our hydrogen on this.
You need to change to 3 to
what did I
6.
miss?
You can put it on the left side. You can put a 2 in front of the hydrogen to make that a 6.
Okay, let's do that. Okay, so 3 times 2 is 6.
Then you got 2.
Then P is 3. No, I'm sorry.
8.
P,
8.
2. P is 2.
Oh yeah, 2.
Okay, now my oxygen got changed for 8 plus
8.
9.
17.
And it matches up.
Okay, 3, 3, 3, 3, 17, 17, 6,
Yeah, I got it.
6, 2, 2. You just need a 1 right here. Okay, y'all got that one? That was pretty good. That was a good mental little challenge puzzle.
Can we do 15?
Hey, you
Okay, I said I promised 5 next. Okay, I promised 5 next.
Mr. Hayes.
Yes.
So when it's in parentheses, do you multiply 2 times 4? Like, would you multiply 2 times 4?
Yeah, like right now, that 1 just multiplies everything by 1, so there's really only 1 P, but that 2 affects it, so 2 times 1 is 2. The oxygen's a 4, 4 times 2 is 8.
Let's do number 14.
Okay, even though these are challenging, who feels pretty cool when you figure them out? Isn't it pretty cool?
Who doesn't?
Even though this is tough, it's a brain game. When you get it solved, you actually are like, man, I feel pretty smart. Because it takes some real brain power to get these things figured out. So, number 5, C6H12O6, that's glucose, of course. H12O6 plus O2. Okay, so this is actually a reaction that's the opposite of photosynthesis. It's actually called respiration. It's how cells break down the glucose and get energy. And that's what we're doing right now after eating lunch. And we are exhaling CO2. That's why we're waiting. And you ever breathe out and feel your breath is warm and moist? That's what you're breathing out. Is from your cells breaking down the glucose in your food. You're breathing out CO2, and the moisture in your breath is the water vapor out of your breath. Okay, so starting with C, how many we got?
6.
How many H's?
12.
How many oxygens?
8.
Good. Because you got these 6 and those 2. So we're going to do the same thing, CH and O. Okay, how many carbons over here?
1.
How many hydrogens?
3.
2 here. Where'd you see 3?
Oh, no, I was looking up.
Okay. Oxygens?
3.
Yeah, there's 3. Okay. All right, so again, oxygen's by himself here. As long as he stays in even numbers over here, he'll balance. No big deal. So oxygen's not the most of my concerns right now. Hydrogen is the biggest difference. So between 2 and 12, I want to try to get him up.
6.
So let's put a 6 here. Okay, so 6 times 2 is 12. Then we have oxygen is now 6 here, but he's 2 here. So what is that? 6 plus 2.
8.
Okay, 2 is 8. 6 plus 2. And then look across 1, 6. So let's try to get this one carbon to go up. So let's go to 6 here. So carbon is now 6. Oxygen is 12 plus this 6. 18. 6, 6, 12, 12, 18. Excellent. Even number, easy to solve. So what divided by 2 is 18?
9 divided by 3. Oh, wait. Not yet.
9? 18. Oh, that's
You have that 6 on it, so you have to minus 3 off of that.
What?
Off of that coefficient.
Yeah, so you put 6.
You have to put 6 there.
where
Because
at?
that 6, you divide it by 2, and that's 3, so you subtract
Okay,
it
so
off.
look.
Oh, yes. I'm sorry, my bad. I didn't count for that.
You're like,
Thank you.
You're like, what are you guys talking about?
You know what was going on in my head was I've solved this problem before. I'm thinking I don't remember 9s being in here. Yeah, I missed this. So you guys that saw my mistake, good job.
6.
I wasn't counting for that, so I need to be at 18.
6.
So 6 here.
Yeah.
So 6 times 2 is 12 plus that 6.
18.
Okay, so now we have 18 oxygens, and that would be a 1 here. Okay, good catch, guys. Okay. O,
So it's just swapping
H,
atoms.
C.
It's
Okay.
swapping the hydrogen for the nitrogen for
Okay, how many potassiums, okay?
1.
1.
How many nitrogens?
1.
1. How many oxygens?
6.
3 plus that, 3. And we're going to add them because they're plussed, okay? And then H's?
2.
2. C's?
1.
1. Okay, over here, KNOHC. KNOHC. All right. Over here on this side, how many K?
2.
How many N?
1.
1. How many O?
6.
Good. How many H?
1.
How many C's?
1.
All right. So I look across.
Those are matched up.
The hydrogen
Yeah.
and the hydrogen and the
Okay, I'm trying to see what to start with first.
hydrogen.
KNO3.
It's
Start
easiest.
with the K's.
Hydrogen's because it's the easiest because it doesn't conflict with more.
Yeah, it
No,
does.
say again why you're saying hydrogen.
Hydrogen conflicts with nitrogen, oxygen, but potassium conflicts with nitrogen, oxygen, every time.
Yeah, they're just kind of rearranged, and we'll talk about what these rearrangements are called later. But let's go ahead and just start with hydrogen. It's a 2. Let's try that. So 2 here. N now gets changed to 2. What is oxygen get changed to?
6.
6 there plus that 3.
Oh.
9. So let's look across 2. Let's go ahead and get our potassium up. So 2 here. Nitrogen changes to 2. What's our oxygen change to?
9.
12.
9.
And we're done. No, we're not. Yeah, we are.
2, 2, 9, 9, 2, 1. That's it.
So it's just 1, 1 and
Okay, so SN. NO2.
What number is this?
18.
18?
Yes.
just 1's right here.
P3, PT. Platinum.
We got
3 and 4. Yields.
this 18?
SN3. How much time do I have?
What time do we get out of here?
It's
18. We got 6 minutes.
Okay, maybe I can get it done in that time. PT. I've solved this one in class today, so I can't remember how difficult it was. Oh, 2.
What's that hard?
This one wasn't that hard for me.
Okay, so SN, that's actually 10. Here's an easy way to remember it. The way I remembered it when I was writing the periodic table is sin and 10 sound the same. Like if you sin, you're a sinner, right? Sin and 10, so I remembered it that way. So SN is 10. How many of those do I have?
1.
Okay, then I have nitrogens. How many?
4. Oh wait, yeah, 8.
4 plus that 4.
Oh yeah.
Oxygens.
4.
8 there. Right? Am I thinking right?
Yeah, 4 times
Okay. Platinum is PT.
3.
3.
You go so fast, man.
I'm just counting them up. I'm not actually solving yet. So SN, I'm going to copy these over. SN, N, O, PT. Okay, count these up. How many SNs? 3. How many N's? 4 plus that 4. Oxygens.
16.
4 times 2, 8. PT, 1. So, okay, my rationale is I hate things in parentheses. I'm going to avoid those at all costs. SN is by himself. I know he's 3 and 1 here, so I'm going to work with him right now. So I want to get this one up to 3 at least. So 3 there. Nitrogen changed to 3.
Is this 18?
No, 3. This is 18, yeah. Nitrogen changed to 3.
12.
Plus that 4. Am I right?
12.
It's 12.
Oh, my bad. Sorry. 4 times 3. 12. Plus that 4.
16.
Okay, and then, of course, oxygen, 2. 3 times 2. 6 times 4. 24.
Oh.
Okay, if I get off on my math, let me know. Okay. Then over here, so I got that. Can I get nitrogen to go to 16?
Wait, what?
Well, I don't want to work with nitrogen yet.
3 times O is 8. 8 times what?
3 times this one?
6. 3 times O is 2 is 6. Is 06. 6 times 4 is 24. Yeah, okay. I was just working it out loud.
Okay, no problem. Okay, so let's look at platinum. Let's try to get him up. The reason I'm looking at platinum is because he's not in those parentheses. So he's 3 here. So let's try to get this one to 3. So 3. Nitrogen's going to change. So 3 times 4, 12, plus that 4, 16. Oxygen now, 3 times 2, 6 times 4, 24. Does that solve it? Awesome.
Can you
1.
have enough time?